Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. A stone is dropped into a pond causing ripples in the form of concentric circles. The radius r of the outer ripple is increasing at a constant rate of 2 centimeters per second. When the radius is 5 centimeter, find the rate of change of the total area of the disturbed water, right? So I want you to visualize this. I mean, I don't think a diagram is required. Now, you drop a stone, and that's causing ripples in the water. And those ripples are taking the shape of a circle, right? So you can imagine that to be an expanding circle. And we all know what is the area of the circle, right? So we have a circle which is expanding because of the ripples. So if I want to call out the area of the circle, what's that formula that I need to use? I know that my area is equal to pi r square. I'm going to call my radius of the circle r, right? And my area is therefore pi r square. And so that's information number one. Now, the information number two is the radius r of the outer ripple is increasing at a constant rate of 2 centimeters per second. So here I know that my radius is expanding, which means my area of the circle is also expanding, but it's expanding at a specific rate, which is your 2 centimeters per second, right? So that's your information number two. And then we've been asked to find, as these ripples happen, at some point your radius hits 5 centimeter, right? And at that point of time, what is the rate of change of the total area, right? So whenever we've been asked to find rate of change of a parameter, that's most often with respect to time, and in this particular case also we have been asked to find the change of area with respect to time, right? So the rate of change of area with respect to time. So how do we represent that? It's nothing but your dA by dt, right? And what's your dA by dt? I have the formula as pi r square for the area. So what is this? It's nothing but 2 pi r times dr by dt, right? So dA by dt is nothing but 2 pi r times dr by dt. And what is my dr by dt? It is 2. So I have 4 times pi r. And what we've been asked to find is, at the time when your radius hits 5, what is your rate of change of area? Not too difficult. It just calls for a substitution dA by dt at r equals 5 is 4 pi into 5, which is your 20 pi, right? And what is the unit? dA by dt, your A is nothing but expressed as meter square, and your T is nothing but your time. So therefore it is meter square per second, right? So that's your rate of change of area. So the answer to the problem is nothing but 20 pi. Let's highlight our final answer in pink. So there we go. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.